So let's dig a little deeper into feature crosses. They can be great, but they can also cause some problems. In particular, if we're crossing sparse features. For example, maybe one of our features is the words in a search query, and the other feature might be the unique videos that we have to look up. So now we have maybe millions of possible words, maybe millions of possible videos, and we're crossing those, we're going to get a lot of coefficients. All of that means that our model size is going to explode, taking memory, possibly slowing down runtime. And a lot of those combinations are going to be super rare, even if we have a lot of training data. And so we may just end up with some noisy coefficients and possibly overfitting. So you know the answer. If we're overfitting, we want to regularize. And now we're going to say, can we regularize in a way that also will reduce our model size and our memory usage? So what we'd like to do is just try to zero out some of the weights, in which case we won't have to deal with those particular crosses. This could save us RAM, and this can also potentially help us with overfitting. But we have to be a little careful. We don't want to lose the right coefficients. We just want to lose the ones that are sort of extra and noisy. So what we'd like to do is explicitly zero out weights, and that's what we call L0 regularization. It would just penalize you for having a weight that was not zero. But that's not convex. It's hard to optimize. It's sort of a combinatorial problem. Instead, what we do is we relax that to an L1 regularization, which just penalizes the sum of the absolute values of the weights. And by doing that, we still encourage the model to be very sparse. It'll drive a lot of those coefficients to zero. And that's a little different than L2 regularization, which also tries to make the weights small, but won't actually drive them to zero for you.